Hello everyone. Happy to be there? Yeah, you look sleepy. Hey, come on. Welcome to the Træfik talk about a scalable and a highly available edge router. If you want to follow the slides, you can take the barcode right now. You have 30 seconds and then let's go. The slides are already online, so you can see them after the talk as well. Okay, sounds good. Let's go. First of all, it's where you can find me on the internet, just in case, but we don't really care. I'm currently working as a freelancer for Containous, the company behind Traefik project. If you want to use the slides, it's not for right now. So Containous is a company believing in open source and providing traffic and support for Træfik. That's all one need to hit by making money. So before jumping on the technical details, I just want to start with the why. Why did we build Træfik? So the consideration of evolution around software design is a bit of cyclic history, always the same kind of trends, and then you change and you change. So the current trends is microservices. What microservices in the software architectures bring the premise was everyone happy, something clean so you can focus on building application, providing values. However, everyone here know what happens when you start a new architecture. You start fighting the system, the other teams, you start running in trouble and shaving yaks, spending time on non-valuable things. So main concern when dealing with that bunch of services is where is located the service I want to reach. There were a lot of tools that exist since years that provide facilities, features to deal with that. I'm not going to have an exhaustive list from container to service mesh. You have a bunch of tools. But we came to the realization that for each of these tools, there were some complexity in it. So that one is a common joke about YAML, which is a language for describing configuration that has its pros and cons. One of the big cons is the tabulation. Today, all these tools are using YAML, meaning you need to write configuration. So for each tool, you need to go to the documentation, find the right element, and iterate until you can do whatever you want. And for us, in the area of entering a platform with an edge router or reverse proxy, you might have tried a lot of tools. Each time you have to write configuration. And also it means it's quite static, or you need to start templating and doing in stuff you don't want to deal about. That's the reason why we built Træfik. We wanted something simple. It might not cover all use cases, of course, but the goal is to stop wasting time on writing configuration. Let Træfik deal with your application backend system and focus on writing code and deploying that code in production. That's the idea. Træfik itself, the project. It's an open source project that you can access for free. The source code is on GitHub. It's on MIT license. It has a lot of stars, contributor download. So of course it's not a project like Kubernetes, it's not that big, but it starts to be a trustable project. And obviously it's open source, so you can make it your own, you can contribute. From the documentation, the typo on the doc, to a new feature you will want to implement it. It's not our project, it's your project as well. A tiny one that I like, you have an issue with Træfik, we even thought deep dive to the community. You just have to use the binary to create an issue on GitHub, so you don't have to search for where should I write my first issue, or it will take care of everything on your machine. So the meaning is we trust the community, and without the community, we would not be on the current state of the project. So a bit of school concern, the core concept in Træfik. How does it work? I mean, it's a tools in action talk, right? So remember that big diagram? Yeah, so let's start simple, just to understand the concept before showing the code. So you have external users that want to enter your platform. That's what we call Ingress in Kubernetes, because people want to reach your platform from the outside. So we are not talking about service-to-service communication. We are speaking about edge routing, entering your platform. So you got your external users that will use your external domain name, and Træfik will take care of passing the request to the right server, collection of server, load balancer, whatever backend system on your platform. This is the concept. We call sometimes this reverse proxy. Inside Træfik, the main concept is a provider. Træfik needs to be fed with information about where is your application, or where are your application, because we are in microservice, remember? So in that example, we connect Træfik to a Docker daemon. It could be Docker Swarm, it could be Kubernetes, it could be Azure Service Fabric, Consul, and the list of providers is long enough to cover your needs. Once you have configured Træfik to listen to provider, Træfik has the knowledge of which service come in, come out, scale up, scale down, whatever you do with your deployment. So that's the first concept. Træfik feeds itself with provider. Then the only thing you have to configure after the provider, it's the entry points, because that part cannot be automated. I mean, how can I know in advance the domain for your application? So that part you have to configure, at least the base host name, and you can also add the information for your certificate system. We'll see an example. If you want to add authentication, so these rules are your rules. That's the only valuable part that you need to configure. On the other side, we have the backends. So you don't have to take care of that. You can define statically or with an API, but that's not the point. The point is Træfik already know and watch, in that example Docker, each time a new container with an application comes in, then it creates internally the knowledge for that application. It's a backend. So the backend can do load balancing, you can add canary base or green, blue, or a lot of different ways to send the request to the backend. So we have Træfik, provider, front-end that you configure for entering the platform, and backend, which is internal Træfik knowledge about your application inside your providers. Finally, we have the concept of front ends, which link entry point and backends. So the front ends are as well configured automatically. This is where your routing rules are implemented. Once Træfik know that if you want to enter the platform with that path or based on that host, it will determine which backend to use. This is done automatically as well. So the only points you have to manage in Træfik are provider configuration, I want Docker Kubernetes, and the entry points. Træfik takes care of the rest. Let's see that on a real-life request with a bit of dynamic. So you have your HTTP request entering your platform. So entry point is listening, receive the request, and determine which front end should the request send to. And then the front end will say, okay, I will apply a set of rules. I do the routing part. And finally, I have to find the right backends to send my request to. And then the requests are forwarded to your backend server. Once the response come back, Træfik just gives the response to the requester. That's a reverse proxy. in practice, if you reach backofficedomain.com, it's HTTP on that example, so it reached the port 80. Then you have a routing system in the front end that detects the host header that say, oh, I need to send it to that backend, which corresponds to a Docker container. And the backend knows the private IP of the container, so it will send the request to that container. Obviously, Træfik has a lot more feature. We cannot cover everything on such talk. And since it's a tools in action, let's see how it works. So first example is with Docker. Can you raise your hand if you are not at ease with Docker or Docker Compose? Okay, 1%. So sorry, I will try to keep it simple. So this is an example of Docker Compose in YAML syntax where I declare, so that's Docker Compose for describing application run on Docker. I need to create that application entry point, which contains Træfik. And I configure Træfik with 4 flags. I tell him, listen to Docker. That's the provider we saw earlier. And I tell him, by default, the domain is mycompany.org. Every application will be under that domain. I also want to configure HTTPS by default. We support Let's Encrypt out of the box. So in that case, you don't have to care about certificate. Just add your credential for Let's Encrypt. And once this application will be started, it will generate a certificate and install it. It will also take care of renewing it 2 weeks before the end of the certificate. So you don't have to care about requesting certificate and validating. Træfik is doing that for you. The last line, the volume, is just to provide a path for Træfik to access Docker. If you would have used, let's say, Azure Service Fabric, you had to put some variable with your credential to let Træfik being able to request the API. That example is the most simple we can find that works for a lot of cases. Obviously, we can also provide very long configuration file in TOML format, but that's not the point, it's for advanced use case. Let's Encrypt, can you raise your hand if you are not at ease with Let's Encrypt? So it's a system where you can have free SSL certificates. The idea is that you request a certificate for a domain, and in order to get that certificate, you need to prove to Let's Encrypt that you are the right person, just to be sure not someone else can reach a certificate for your own domain. So there are 2 main validation systems, by HTTP or by DNS. In the first case, in HTTP, Let's Encrypt say, okay, you want a certificate for that domain. Can you prove by writing that token on that URL behind that domain? So you have to create a temporary text file on your web server. Then Let's Encrypt will say, oh, I see the token. Okay, so you're the person you claim to be. Here is your certificate. It's free. It's backed by the Mozilla Foundation and a lot of big names. And it provides even wildcard certificates. The only thing is, all certificates are only 3 months valid for a good reason, because they provide you a way to automate those requests. So that's why we integrated that in Træfik. You don't have to care about renewing certificate anymore. The second validation is based on DNS. You just have to add an entry on your DNS name to prove that you are the owner. And Træfik automates both of these verification. If you have an automated DNS provider, like AWS Route 43, you just have to add your credential and Træfik will add and clean up everything in the DNS. So again, you don't have to care about this. Just configure Træfik one time and then certificate for everyone. So now we have Træfik configured to listen Docker, and Træfik is also configured to provide HTTPS by default. So we can start a simple web server. That's the most simple. So here is Nginx, which is a web server. And you just need to configure using labels. So the idea in Træfik is the developer in charge of starting the application will know the right information. In that case, the website is www.mycompany.org. These routing information are provided by the team in charge of that application. One label, and once you start this container, Træfik will gain knowledge and start routing to that application. Remember, we configured with the default domain mycompany.org. So all requests coming to mycompany.org will still be not found pages, because here we configure www. So we configure the simple subdomain. We could configure whatever we want for whatever application. WebSocket is built out of the box, so you can have whatever WebSocket application, it just route correctly. It's an HTTP protocol, so it works. In that case, that's a nice application to provide web terminal if you don't want to deal with the CMD or bash of your end users. And it's running inside the containers, and you can use whatever web browser, even a tablet, to access it. We can add context. I used to work for CloudBees, and I'm at ease with Jenkins. So in that case, Jenkins is an application you can configure to say, hey, answer request when they come in /Jenkins. So in that case, if you access the mycompany.org with two labels, we say to Træfik, hey, everything coming on /Jenkins on the default domain, send it as it's to the backend, to the corresponding container. We also had to manage multi-port. By default, Jenkins exposed two ports, one for HTTP and one for the agents. So in that case, you have to tell Træfik, hey, you have two ports. It's automated, remember? So you have to explain which port is the one you want to route the application to, because it cannot know in advance. Same example with a rewrite. So in that case, it's an application serving request on localhost 3000 / and nothing else. So I changed the rule. Compared to Jenkins, it's not path prefix, but path prefix strip. So in that case, Træfik received the request in mycompany.org /git server, remove the /git server, and send the request to the backend. So this is the simple. You could also add custom rewrite rules with regexp and a lot of more configuration. But here I already covered, let's say, 60% of the use cases, just with a few labels. Same example here, Gitty is a Git server that you can run locally, a la GitHub, and it contains two ports, one for the Git in HTTP or HTTPS, the one we are using, 3000, but you also have SSH. So we want to tell Træfik, don't route the HTTP request to SSH, which does not make sense. Who here is at ease with Kubernetes? Raise your hand if you are at ease with Kubernetes. Okay, so we do Kubernetes since it's also the new trend. It works. So the idea is to say Træfik is inside what we call an Ingress. Instead of other, you have different provider. And so the Ingress takes care of feed me with the routing information, and I will implement them to send requests inside the pods. So it works exactly as in Docker, but with the native Kubernetes integration. So this is a standard Ingress declaration in Kubernetes. Sorry for person not at his. So only difference with the default one, which is generally Nginx as a de facto standard for Ingress. You comment out or replace Nginx by Træfik, and it just works as it was working before. So you don't have to choose. You install both, and you can select the one which is more fit for you. So we don't have a lot of time. I missed a lot of things. We could do tracing. We could do a lot of backend system, mirroring, routing, rules for circuit breaking patterns. There are so much feature, but I wanted to focus on the message. We want to keep things simple. If you want to build something very big and complex, Træfik might not be the tool you want to use. The goal is to not waste your time on configuring this kind of edge routing. Focus on your service mesh or your application, something more valuable. So we talk about high availability. The thing with Træfik is it's single node based. Since 1 year and a half, we have baked a beta function named cluster that allows to run multiple Træfik instances. So if one instance goes down, then your Træfik is still routed by the other, which seems logical. It's not that easy, especially when you deal with certificates. With all that automation, how to be sure that at any moment you don't have two separated instances, because of network failure, that try to gain a new certificate at the same time. Once the cluster goes back to an healthy group of Træfiks, which one will have the right certificates? How do you manage that? There are indeed some complication. So that's why I want to present you a very secret project that we are working on since a few months now. So the goal of that project is to provide an highly available Træfik. If one node goes down, that secret project will be able to route and share the load on all the other nodes. To solve the problem of complexity on lock and distribution, we have a separation of concern. That kind of cluster have two kinds of nodes. So you have the routing nodes or data nodes, data plane in network language, which take care of taking the load. If a new server enters because you scale your application new deployment, there is a control node, the tiny one on top right, that detects the change in the provider as we saw before, normal Træfik. And that control node will say, oh, there is a new one, so I will push that configuration. So one node or collection of nodes has to reach a quorum and decide the distribution and detect events. And once they have that kind of event, they push that to the routing node, the data node, that takes care only of the load. They are dumb. They just route Træfik. They don't have any knowledge. So this allows us to have a scalable Træfik. We can add more nodes to handle more loads. So this is our secret project. And so for the teaser, here is a simple example that I will show you on a video, because I don't want to run on demo effects. So we have a Kubernetes cluster that contains 5 nodes, so 5 virtual machines clustered. I've deployed the very secret project, and I've deployed an application, Who Am I, which just prints a bunch of HTTP headers of each request. Show me which machine treats my request. So that's a basic web server, minimalistic. And I've configured that with an ingress that say, every request entering my platform with whoami.localhost, or my domain name here, will be sent and load balanced on one of the two containers. So here is the video. I will comment it. So on that video, on the left part, you have my loader. It's a SaaS service that will just send a bunch of requests to my platform to show you that if one node goes down, you will still keep a request coming and without errors. On right top, you have the Who Am I application. You see that's a dumb web server that just prints out the information from my requests. And on the bottom part, you see the web UI of the very secret project. So let's start it. So here, that's the initial configuration. You have the 3 entry points and front ends, the concept I show you in normal Træfik. So we have one for the web UI itself. The request need to enter that application. One which is for Who Am I. And the third is just for validation. You see the test on the left, because I mean it's a SaaS that sends a bunch of requests. So you need to prove that you are the owner, or it's just a DDoS attack. So I have 3 applications, one for proving I'm the owner, the dashboard, and my test Who Am I. My cluster consists of 3 control nodes and 4 data nodes. The 3 control nodes are just discussing between each other, and the data node routes Træfik. We have embedded metrics that show us the status of HTTP. If I reload the application, you see everything change because it's load balanced between the 2 containers. So once that sanity check is done, I launch the test. And while the test starts to sending bunch of requests to my platform, I will switch to my terminal, and I just kill a virtual machine in my cluster. So one of the VM goes down with everything inside that can happen. So what you see is that all the cluster is starting to react in order to keep your availability for your application. So Kubernetes reschedule pods, restart container. We detect that one node is going down, the red one, and you see some requests. It's not still perfect. Some requests are still in timeouts because Kubernetes takes time to detect the change because it's default config. You see that we still don't have HTTP error inside the cluster. It's just clients that have a timeout, which is way different. And the cluster recovers by itself. The virtual machine will restart, Kubernetes will restart pods, and everything will go back. But main part of our requests are still in HTTP 200. So we see one machine down, only 3 data nodes. The failed node has disappeared. Still our metrics providing insight about, okay, how Træfik see the load from inside, while on the left from the outside. And finally, the machine come back, and immediately the nodes come back online and start sending traffic again. So this is our working project, which is built upon the open source Træfik. So to know more about that, just stay tuned. So, okay, we have 3.5 minutes for questions. That's all for me. Don't forget to rate me, and any feedback or question are welcome. Thank you very much.
Why would we change the configuration inside Kubernetes from Nginx to Træfik?
So the question is, why would we change from Nginx to Kubernetes to Træfik inside Kubernetes? So my answer is because both are doing different things. They are still edge router. Nginx is adheres a web server, but if you have Nginx, you need also to spend time automating the configuration. In the case of Nginx in Kubernetes, you don't have high availability, and also if you have an issue on the template rendering, because it's just a listener on Kubernetes that render the nginx.conf file and reload the web server. So you still have to automate some things at the routing level. Also SSL. If you want to simplify the SSL certificate, you can add more pods and more applications that will feed Nginx, but using Træfik here will ease your life. Just say Træfik use that SSL. Still, I don't say you should replace. Again, in the case of Kubernetes, you can have both side by side. That's not an issue. You could install for Ingress, even Nginx, Istio, Træfik, and use the right tool for the right job. It just depends on what you aim. Do you want something simple, fast? Do you want Nginx for complex performance or migrating from outside Kubernetes with already Nginx installed? Depend on your use case. So I don't say use it or replace it. I just say consider it does not cost anything to have both in your cluster.
How would you typically configure that your external requests reach Træfik so they can be routed?
So the question is, how do you configure that your external requests reach Træfik? In the case of Kubernetes, right? Yes. So this is a purely Kubernetes question. You have 2 main ways that are both supported by Træfik and the secret project as well. You can, if you are lucky enough to run Kubernetes inside a cloud, a magical cloud, AWS with EKS, IKS, Google Compute, etc., they provide the facilities for that. They have plugins inside your Kubernetes cluster that will take care of creating external load balancer for you dynamically when you create services in Kubernetes. We don't have enough time, but when you have the concept of a service, it creates external access. So when you install the Træfik Ingress Controller, it creates one single service that will take care of certificate and single entry point for the Ingress Controller. If you're not lucky, I recommend you to check Metal LB, which is a load balancer using IPVS that can be hooked to Kubernetes if you're running Kubernetes on Metal. It even works with Raspberry Pi, so ARM architectures. And it's built by backed by Google at least, and it provides the same facilities. If you don't, you should configure Træfik as a service of kind node port, meaning each machine of your cluster will have an allocated port, let's say 10,000. And so you have to manually configure your external load balancer to send the traffic on all machines. And then once the traffic enter one machine, Kubernetes will take care of routing this to the right port, right whatever. So in all cases, you just have to configure one service. Is it a Kubernetes service of kind load balancer or node port? If you are running on Metal, you need an external system managed by yourself, and then it just works. Time's up. If you want to ask question, come see me after. And we have a bunch of stickers if you want some. Thank you very much and enjoy the conf.